Solving an equation involving logarithms on both sides, problem type 2. This is where the equations with logarithms can get to be a little bit trickier. Let's say we have that the log of 3 is equal to the log of x plus 2 minus 5. We have a couple of logarithms going on here. We also have this constant that's not a logarithm at all. So we have a little bit of work on our hands. The first thing I'm going to do is rearrange this equation so that my logarithms are all on one side and my constants are all on the other. In this case, that just means subtract log of x plus 2 from both sides of the equation. To get that the log of 3 minus the log of x plus 2 is equal to -5. Now from here, I can use the properties of logarithms to rewrite this as a single logarithm. The log of 3 over x plus 2 is equal to -5. And now we're back to the problems that we've solved before. This is log base 10, so I can raise 10 to the power of each side of this equation. And since these things are equal, 10 raised to this power and 10 raised to that power should also be equal. So 10 raised to the log of a thing is equal to that thing. And we end up with 3 over x plus 2 is equal to 10 to the -5. And let me copy this onto a clean sheet so that I can work through solving this equation. The numbers are a little bit ugly, but they're perfectly workable if we take our time and we're careful about things. In fact, in order to not deal with ugly decimals, I'm kind of inclined to write 10 to the -5 as 1 over 10 to the 5th, and then use the cross product test like any other proportion. So this is 3 times 10 to the 5th is equal to x plus 2 times 1. So 3 times 10 to the 5th minus 2 is the value of x. And we can punch this into a calculator if we really want to. We can work out by hand. 3 times 10 to the 5th is not that hard to deal with. But if I punch 3 times 10 to the 5th into my calculator, I get 299,998 as the value of x in this particular case. Nice, small, easy to work with number. All right, so that's what an equation involving logs looks like when it gets a little bit messier. Again, not that bad. We can use the properties of logarithms to take something that has a couple of logarithms in it and rewrite it as something that has just one logarithm in it. And then we're back to what we were looking at in the previous problems, where we can raise both sides of the equation to the same power and go from there to find our solution.